Hi, I'm Bobby Balicki from the National Electrical Manufacturers Association, better known as NEMA. Thanks to the U.S. Department of Energy, we are proud to present Bids for Grids, new media for the energy workforce. In partnership with George Mason University and NEMA members, we've developed a series of short educational videos introducing electrical equipment that's used in the smart grid, the electrical grid for the 21st century. This series is going to present a dozen of the most important products that are critical to a smart grid success. Our mission is simple: to make you more aware of smart grid technologies and help you consider a career in power engineering. This edition of Bids for Grids takes us to Waukesha, Wisconsin, where we will visit Cooper Power Systems, who manufactures regulators, a vital part of the smart grid. Here we are in Waukesha, Wisconsin at Cooper Power Systems, one of the leading providers of solutions in the electro industry. Today we're going to learn about voltage regulators and how they help support the smart grid. Let's go inside.
Voltages don't remain constant. They tend to vary over time. And there's a lot of different things that can cause variations. I mean, you might have changes in power demand, or there's resistance on power distribution lines. And all of these things kind of work together to cause voltages to go up and down. Electrical equipment typically requires a constant voltage, usually like 120 volts. And so it's useful to be able to have a device that will adjust this voltage as needed. So voltage regulators really are a means to be able to make adjustments to voltages on the distribution system. You might see it along the line on a distribution power line. You might also see it in substations. And we're seeing an evolution where maybe businesses like large factories want more precise voltage regulation. And so they might have one right outside of their plant. Like Google, for instance, they have very large demand for power, and they have equipment in there that's extremely sensitive, and so they need very finely tuned power voltage levels, and so they might purchase voltage regulators to regulate the power coming into their facilities. Really, probably over the last 20 years, a lot of advances have been designed into these controls. I mean, they have digital processors now, LCD displays. You have software, and firmware, and Ethernet, fiber optic communications involved, and all of these things kind of work together to allow these controls to communicate with smart grid and smart grid enabled power distribution systems.
When it comes to designing voltage regulators, there's really two main aspects of design. We have new product development, which is involved with taking a brand new concept and designing it. Cooper has a structured process for developing new product. We have what we call toll gates and a list of requirements within each toll gate to ensure that we're following the same structure from one design to another. So if you're looking at getting into engineering and you're interested in building things from the ground up, that's probably a good area for you to focus in on. Another aspect of our engineering is what we call engineer to order, or ETO. And that's taking pre-existing designs and putting them into different configurations to meet specific customer requirements. So if you like to build things, then that's something that might be of interest to you. When it comes to fabrication and manufacturing, there's multiple steps in our process that require manufacturing engineering oversight. And here at Cooper, we have things such as blanking, shearing, punching, bending, welding, process that is called E-coat, and what that is essentially a prime paint that goes on the tank prior to assembly. And then all the different methods to assemble the product, take different sub-assemblies, put them in the tank, test them, final paint them, and then send them out the door. So if you're somebody who wants to be down on the shop floor and understand a process and help provide a consistent process every time, then the manufacturing engineer's job is to go down to the floor and prescribe that method and work with the operators.
guess electric utilities are always looking for smart grid applications to improve reliability, save cost, and save energy. And Cooper Power is a leading provider of smart grid solutions. One example is the mini SCADA application that helps to monitor how fast the conditions are changing in the grid. This allows the utilities to take decisions in a timely manner. It also helps to monitor the long-term trends and also to plan and make the maintenance of the equipment based on real-time data. One of the most recent product developments for regulators was the redesign of the control panel to provide more room to include communication options like radios and power supplies. And in addition to these, there were many upgrades to the firmware and hardware that helps to improve the programming flexibility.
Cooper is a great company. I was working on a heavy design project up at school for my master's and found out there's such a thing as a marketing engineer. And I decided that's what I wanted to be. I can interact with people, work with customers to solve their technical problems. And Cooper came along and I jumped on the opportunity to get on board. There's a sales and marketing development program that Cooper initiates. You rotate through the different divisions, transformers, regulators, capacitors, switchgear, to learn the ins and outs of the industry. And through these different departments, you learn how to interact with customers, interact with engineering, develop marketing skills. So I participated in this program for about a year, and then I off-placed in the voltage regulator department as a product specialist. I really enjoy getting out with the customer, and Cooper Power System offers that opportunity. I can go out in the field and work with the customers to program a voltage regulator in the field, on site, instead of being behind a desk and answering phone calls all day long or designing a component.
The power systems industry right now, it's really hot. And one of the things that is really exciting is that we have right now a lot of opportunities for eager students that want to come and want to be successful within our organization. One of the things that we do is that we encourage students to work in internships that are relevant to their field of interest when they're in college. This way, by the time when they graduate, it will make it easier for them to be able to find jobs. Within Cooper Power Systems, we have phenomenal leadership development programs in the field of sales and marketing, which has an engineering emphasis. And then we also have an engineering leadership development program. And by them working on internships before they graduate from college, it gives them the opportunity to already know some of the basics about engineering that will make them even more successful. Our industry is not going anywhere. Our industry is here to stay, and we're solving real problems for real issues. And we'd love to have you here working at Cooper Power Systems.
Today we learned about voltage regulators and how they are being designed specifically to meet the needs of customers in the smart grid. These products are especially needed to ensure the stability and power quality of the smart grid by balancing voltage supply and voltage demand. From Waukesha, Wisconsin, and Cooper Power Systems, on behalf of NEMA, I'm Bobby Balicki.
Mark 5, 23. Action!